Twitch. Good to have you. Which has been a little quiet lately, a little sad, but that's okay. Looks like YouTube's up as well. Always a pleasure to have anybody who wants to stop by and chat. We're decompiling Castlevania Symphony of the Night, and I'm going to go over some interesting things. I had a shorter time yesterday. Kids had off of school, and so we were doing all kinds of fun things at home. And that has to pull me away from decompiling from time to time. If you go to soten.z.dev, you can learn more about the Symphony of the Night decompilation project. We're going to be decompiling some functions from the Richter boss overlay. And the Richter boss overlay is now in... it's in here. It's not doing much, but it's in here. Oh, do I have to add... I might have to go add this to the progress script as well. That might be why this isn't showing up. We should go look at that. I do want to go over a couple other things though before we get too far into this. I mentioned yesterday or the day before, I don't remember what. Project Oblivion and I were talking a lot about the MetroWorks overlay header files, and I was struggling to figure out what the values meant and how they related to the overlays themselves, because they seemed somewhat nonsensical based on the way that we were splitting files. And it turned out that the way that alignment was happening was space was being attributed to the next section of the overlay based on how big the previous one was, but then you'd have the alignment padding that prefixed the rest of that, and aligning it that way made a lot of sense. He was able to show me a gist with the structure for the MWO header, and that was fun. And now we know a lot more. I think Ethan stopped by in Discord and learned a lot of stuff from him as well. But previously, when I was looking at this, there's not a lot of existing tools that will tell you information like that, because the people who used MetroWorks were largely either not on modern systems, or they were compiling for a very specific console. So Code Warrior, I believe, was originally written for the Macintosh. The Macintosh did not have a standardized POSIX shell until OS X in the early 2000s. There was another Unix variant, but not that would have been in common use. So tooling around a lot of the Code Warrior stuff was not really built into a lot of the Unix tools. I like Unix tools because they've been around forever. A lot of thought has been put into them because they've been around so long. And I think people who don't use them or don't understand them are doomed to re-implement them later in worse ways, typically. So I wanted to, I haven't done this before, but I wanted to look at, and I'm going to move this file out of the way for a second. One of the things that, I'll just delete it. One of the things that we have on Unix systems is a tool called File. File has been around since the 1970s, and a lot of times you can use it to tell what things are. So I can run file on, let's see what I have here. Let's run file on the make file. It says that it's UTF-8 text. That's great. What else do we have in here that would be slightly more interesting? Will it be able to tell me that parse overlay is a Ruby script? It does. It knows that that's a Ruby script. It looks at different things, most likely the shebang at the beginning, and says, hey, that's a Ruby script. I don't know if it gets the file name, so I'm not sure that it would know that. But if you did something like file on disks, PSP, EU, and let's go all the way into something like one of these overlay files, it just says that it's data. And that stinks because what good is that? Doesn't tell us anything else. On the other hand, if we ran file on something like the build and looked at, this will be in weapon, right? Oh, come on. Where are you? I want the elf file. Oh, I don't have it in this directory. So let's just choose another one. We could do Maria.elf, for example. It knows that that's an elf, and it'll even tell you different things about it. It's for MIPS, statically linked, has symbols in it, not stripped. So what if we could get that for some of the more esoteric files that we have? And so I started a repo. I haven't pushed it yet, but I think I will, called Decomp and that's how file finds different files, is with a magic file. Usually we don't have custom magic files because they're kind of a pain to write and they're a little different, but now if we run file on that weapon overlay, it identifies it. It's a MetroWorks CodeWord overlay file, version 3. Tells you a whole bunch of stuff about it. And we can use common Unix tools. So I plan on, there's at least two, so this overlay format, as well as one of the PlayStation image formats. I will be adding both of those, and if other people want to contribute to that, it'll be called Decomp Magic. And I'll talk more about that in the future. The other thing, so I just mentioned this PlayStation image format. I was going through the repo, looking at different files that are in the disks, thinking, what things would I want to know about that file doesn't know about yet? One of those is going to be like the main executable. But file already does know about that, and there's magic, and there's a magic file called console that defines a bunch of PlayStation and other data formats. The streaming files are interesting. I don't think we're extracting them correctly yet, so I want to make sure that we're extracting those first before I'd write any magic for them. But the last one was this TIM file. Is there the same one for the PlayStation bins? Unfortunately, I don't think it can be written for the PlayStation bins. And the reason is MetroWorks overlays have, that's a question from Dizik. He says, that's nice. Is there a way to do it for the PlayStation bins? The way magic works, and I can open that file and show you, is you basically put a bunch of rules. Where do you expect data at different offsets or different patterns? Let me actually put the full path to that. And so you need something to grab onto that. And I want to do that here less. That is either searchable in the file or otherwise. And so we know what the layout for these for the PlayStation is. They start with data, but there's nothing really inside here that is unique and says that what this is. Eventually, you might be able to go far enough until you get to the text section, but there's no header or any other like metadata in these files. They're basically just binary blobs that other parts of the system know about. Or they put some data at the front, but that is very specific to to this, and maybe that's enough. Maybe so the overlay data that's in these files is Symphony of the Night specific, and so we could write magic for Symphony of the Night stage overlay files. That would be easy, and well, I don't know why that is triggering Allison. That'd be easy. So what does magic look like? They're relatively simple. I've never written one before and was able to do it in 20 minutes or so. But basically you have just a pattern file. This says at offset 0, expect a string. That string should equal MWO, and then everything else in this is what type of file, what do you want to name, or what string do you want to print if that matches. And then after that, relative to that previous match, with no additional offset, we want a string, and that's either going to be 1, 2, or 3. I've never seen overlay version 1 or 2 files, so I don't have any additional data for that. But then for 3, the double indent means if this previous rule succeeded, go to the next one. And we're just going to go down at different offsets, grab a little endian long, etc., and then print out these things along the way as you go. My naming right now is not consistent, and I'll fix that. I started one naming format, and then I looked at how the PlayStation prints things out, and I'm going to switch to that format. And then you could put a MIME type if you want as well. And so in this case, it's just data. There's not really any more specific MIME type there. One way to look, so in this case, we knew what the shape of that header file, or what that metadata was. There's a header file that specifies how that's organized. What about things that are less clear or maybe variable in their layout? I've used this tool in the past. I feel a couple different ways about it. But this is a hex editor called ImHex. It's based on ImGui, which I think that's probably my biggest problem with it. It doesn't use native widgets. It draws everything custom. And ImGui is, it has its own philosophy for how to draw interfaces. And it's not necessarily how it draws or how it looks. It's that by not using native system things, keyboard shortcuts and other accessibility things just don't work. So I was looking at this, and this is the TIM image data format. Let me grab a site that has details on that. So thankfully, like a lot of this stuff is documented, but it's not necessarily codified anywhere. It's not, nobody ever went and wrote a magic file for this. So you can't just run file on this. It just looks like binary data. But we have, a specification, and I'm guessing that these diagrams came from the Sony documentation. I haven't gone back to look specifically, but we have 64 bits at the beginning with a tag. So whenever we have this, we have a static tag, so 1 byte, that's always going to be 10, and then a version, and as far as people know so far, the version's always 0. So we have 16 bits at the beginning that we basically can anchor off of, and then an optional color lookup table, and then an image. And so I was looking at that. ImHex lets you define C-struct looking things. They're not actually C-structs, and unfortunately I don't think there's a way to export them either. There should be. I think that would be nice. But you can define bit fields, which act a lot like structs, enums, structs themselves. And then this will go through, and it will kind of highlight everything for you, and also give you a graph of what that looked like based on the file that you're importing. My the hex editor that I use most is called HexFiend. It's a Mac app. It lets you do something similar, but you have to write it in TCL. And this is just much more terse, looks a lot more like a C struct. So I like it a little better. The neat thing about this, so we have our TIM file struct. It's going to have an unsigned 8 tag, like I said, a version, some padding, and then a format that we'll go look at the format. But then based on the content of that format, we can decide whether or not we're going to have different fields later on. So if the color lookup table is present, we're going to have a color lookup table. Otherwise, we're not, and we're going to go down to the image. We could have one of 4 different image formats in here, and so the image field will come up in this structure, and it'll be the correct one, and our pixels are broken up exactly like they are, and you can't really see it because this is it's a lot of dark colors, but this color on the side here in this column after the field name is actually the color of the pixel, which is really cool as well. So the functionality of ImHex is really nice. It's really the interface that I not even the interface. The interface is fine. I just have so many like keyboard hotkeys and shortcuts that I use for navigating text, and they don't work, and it's frustrating. And so maybe it's me going in and figuring out how key bindings work for ImGUI and making that more Mac-like. They did, you can't see it because I don't share the menu bar, but they did recently move the menu bar into the real menu bar, so it looks less like a Windows or Linux program and more like a Mac program, which is nice. So yeah, I like ImHex. I like the functionality, and maybe I'll do a little bit more there. The other tool that I've used quite a bit for formats, less so binary formats and more Mac formats, is a parser generator called Ragel. I like Ragel a lot, and it started out like as a university research project, but it's not, as far as I can tell, it's not maintained anymore, and so nobody ever wrote Rust bindings for it, for example. What Ragel does, let's see if I can find Ragel. It compiles, basically it builds a state machine. So you define rules. Most of the time they're defined as regular expressions, but basically you can write a BNF. And then it compiles to a really gross switch statement that's very optimal and runs really fast. And so you can build protocols and data formats using basically BNF, which is pretty nice too. And then it compiles to one of these languages. There's a couple others that it compiles to as well, and it works really well. And so it'd be nice to, like, I really would like to see a Ragel implementation for Rust, but it doesn't exist, unfortunately. So anyway, that's data formats, and sometimes we have documentation for them, sometimes we don't. Sometimes somebody kind of stumbles over a treasure trove like the MetroWorks header files, and we learn more about them. Yeah, Flex and Bison, of course. I've actually never used either of those. There were a few for Java as well. I did work on some data formats quite a while ago. One that was a provisional RFC as well, and I left the company and nobody ever picked up completing the RFC. Yeah, I'm trying to figure out or remember what the Java one was. I can't remember offhand. Anyway, let's get back to compiling things. So yesterday I screwed up my tabs. Is this the one we were working on? Looks like it. So there's some work that I have to go back and redo, but we're at about 86%. So this is a function that seems like possibly the main state machine for Shaft's orb that floats around when you're fighting Richter if you have the holy glasses. Spoiler. And so far it's been pretty straightforward. I'm not expecting too much complication. There was some stuff in here that was that had some ordering that was a little off, but we'll get to the PSP version eventually, and that will help with that. I think what I'm going to do is try to find some of these go-tos and get rid of those. In this case, there could be some control flow that results in the same thing here, but there might not be. So this looks to me like if this temp is less and temp v0, we're going to do this inner one. Otherwise, if temp v0 is not, we're going to do that. Otherwise, we're going to do this, and we don't need this last. Else, if this becomes an and, I think that's the case. Let's, GCC was not happy with me regarding that. So we're in this general area. So these are not quite right. So I think, let's try this. We have two different cases, basically, or two different results that need to happen. This temp S0. So I actually think this might be, or this other case. And then we just need these two. And let's try inverting those. Oh, I missed this. So not quite, almost, but not quite. How is the rest of this looking? Yeah, there still is a jump down here. So maybe not, maybe it was this original one. Let's back that out. And let's try just putting those back the way that they were. So we get the shift. Yeah, this is odd because these both. The outer if seems superfluous. Oh no, we're switching the order. I see. Okay, so let's try this. Hmm. So varv1 underscore 2. The issue that I think is happening is it's defined as a 16-bit value. And so we're getting an additional shift. Let's go make it a 32-bit value and see if that changes. So the shift. Oh, the shift may be coming from these. That's a little better. I'm gonna keep going. I think that'll be easier to do on the PSP version anyway. So let's keep going down. Some ordering issues on 206. That looks better. Register issues. There's an additional 0 assignment up here. This var A1 I think is gone. Don't know if it's going to be causing any problems, but it's not necessary. The store here, yeah, this is around where we were. Yeah. Okay, so this is what we were looking at yesterday, and I went through and did all this. Some of this is not, it's not going to change how the PlayStation compiles this or GCC compiles this, but it definitely will change how MetroWorks compiles this. And I wasn't sure here whether or not these were being calculated inline or not. I really feel like they are ultimately going to be calculated inline, but we will see. This was a -4. And I think that Oops. Save. I like doing that, don't I? How much of this did I lose? None of it. Good. Let's see. So we're gonna grab all of this. So the first thing we run into is the Richter position being out of order. And I think I had created a Rick pause X and a Rick pause Y. And the cast here suggests that it's that this should be a 32-bit value, even though what it's reading is a 16-bit value. It may or may not be the case. Anytime I see S32, especially for positions and things like this, my guess is that they were just writing ints. Most people don't use shorts or unsigned shorts. That would probably be my preference as well. But sometimes we do need to use the specific, like very specific widths for the types. Most of the time it doesn't make a difference though. All right, so there's some stores back to the stack here. Possibly this. Yeah, so this timer value, where's T1 coming from? No, it's the Rick pause X and pause Y. And that is getting pushed back to the stack, but just in a very different order. Is it possible that these are being done after the timer? Doesn't look quite right. It's also possible that the timer is being pulled in. Let's do this. Let's say var7. Let's try a ternary. No, it doesn't change anything. This is a store to the stack versus a variable. There's a ton of variables still here that we need to get rid of. So I'm not going to worry about those until some of that's cleaned up. So I think that's probably the next course of action, is going through and cleaning up things. What I want to do is figure out where some of these variables are needed and where they're not. So I'm going to kind of go backwards and attempt to clean up a bunch of these variables. So this looks like a var s6 minus equals. The order seems backwards though, but and kind of similar here. We're setting var s5 to plus equals. Temp FP we'll call angle. Oh yeah, we have to fix the loop here. Forgot about the loop. That was lost yesterday. Yeah, I think var S7 direction, that seems reasonable. Thanks, Dizik. Hey, roaming. Good to see you. So let's look for var S1 and see where that is. We don't need the increment. Call that J here. Try inlining this decrement. And that all worked fine. So SP30 is some type of flag that only gets set. Sorry, I'm scrolling. Set when the timer is at 0. Oh yeah, we looked at this a little bit too, and in the particular step is 11, which I don't recall what that was. Just a register issue there. Yeah, I think it was walk. One of the, yeah, I agree with that. All right, so now we're kind of getting into var S5 and S6. So I tend to call these like offset X and offset Y. We could call them prim X and prim Y. Basically, we're setting the left side and then the right side of this. So let's do that. These should be set near each other. Hey, Spring Quetzal, good to have you. Good luck on your test. Hey, Roaming. I haven't said hi yet. Good to have you back. Let's Disick says Tempest 4 looks like a scale. Yeah, and this, my guess is we're taking square root and then divided by random constant. Let's see if that random constant is a meaningful. So it's hex 7000. So we're shifting by 12. So Tempest 1 is distance X, or distance Y, sorry. I'm going to move these into the correct order as well. And then Tempest 0 was distance X. So the value that comes back from RTAN is going to be a PlayStation format fixed. Our distance X and distance Y. Why would we be shifting these? Temp S4. Why are we shifting them by 12? That makes them, because the value that we get from cosine and sine are PlayStation format values. We're shifting those to the right by 4, which moves the fractional portion. So PlayStation format fixed values, you have 12 bits for the fraction. 19 for the, or 20 for the integer portion. Shifting over by 4 to the right, what did that get us? I almost wonder if that is actually a division. Let's try it, see. The shift over by 4 plus the shift over by 8 does give us just the integer portion. And so maybe it's to handle any carries that might have come from here. So this is I think the 7000, getting back to this, I think this is going to be the same as float 7. So we're dividing by 7. So okay, so we're taking this distance, we're converting it to a PlayStation format. The shift right is not working out. So this might be a multiply by oh, what would that be? Where's my calculator? So we want 12 bits. Just be a multiply by 1,000 and then a divide by 7,000, but why? And yeah, it does the same thing there. Yes, 7,000 is 7,600. No, 7,000 is in what we call FLT. 7,000 is 7. If it was fixed, it would be 7/16. That would be correct. And that will give us the same thing. What I'm not getting, and basically we're getting the shift. The C and the 2, those are getting combined in this version. And that seems to be what the issue is. Yeah, my assumption here is that what they're doing, so they're, this is Pythagorean theorem, what is the different distance of the tangent, right? And so they want to take that integer distance and convert it to a PlayStation fixed point number so that they can do this math down here. Because our cosine and our sine are going to return PlayStation fixed point numbers. And then they're shifting all of the fractional portion off eventually. And what they're left with then is the integer portion of that calculation, which they're adding to prim x and prim y. That's kind of my thought as to what's happening. So I'm going to call this just distance. Yes, that's fine. Nothing's using this anymore. Okay, that. And yeah, I like the direction name for var S7. Yeah, so there is another shift up here. Oh no, it's part of this calculation. Okay. Yeah, so why it could be that these are happening separately. We could try that. Sometimes the optimizer won't combine those instructions. Yeah, there's something else going on. Either the type is wrong, the shift left by 16 is no 31. Oh, that may be a mod. So if we're not dividing by 7,000, what if we mod 7,000? Not quite. There's something else funny going on. Often when there's a shift right, basically we're pulling off the sign bit here. So usually that's the result of some mathematical operator. And so we're using these logical shifts. And that may be the issue. So shift right by 2. Yeah, I'm not sure. It might be time for the PSP. The PSP will answer all the questions. Is there other things that I can get rid of? SP30 is some type of flag. We do need it. I did think that some of these temps, and we'll just ask the PSP. PSP, what can you tell us? So let's find a very unique value. The anim set is interesting. I think this is going to be negative. Let's find that. I don't think it's going to be a very interesting value. And I'm not sure how it's going to be represented on the PSP. So it's either going to be like 8005. Is that right? 8005? Put the square root function into a parens. That might do it. So I'm never sure when SPIM is gonna, or the disassembler is gonna spit this out as a negative value versus just the regular value. So the other thing, this 3080 is possibly unique. I haven't seen that. Oh, the 8252 might be good too. So let's try some of those and see if we can find 8252 though could be a negative value as well, and so it could be represented as that. Oh, I need to re-export this. I think I have it out here, but I can't keep it out here. Splat dot. Okay, we only have one function with 8252. It's a good choice. And it does show up twice in disparate sections. The 7,000 should look the same. And yeah, that is pretty unique as well. Yeah, I tend to think of random hex numbers with like a lot of different numbers in them when I'm looking for unique value, but 7,000 is just as unique. There's not anything that typically would have that value. I don't know why my mind goes to like the most random looking ones, but that's what it does. I'm gonna rename this scratch. It pulled the first global symbol it sees. That's not necessarily what we want. We'll see if, first of all, does it compile? It does. Not very well, but it does compile. And we'll look at M2C and just kind of follow along, see what looks good, what doesn't. First thing is pushing the argument to the stack. There's an assignment of the value 4 to the stack. I don't see a 4 anywhere else. Where is SP50 used? It's used way down here. So we do have a, that was where I think we were just working. Not quite. It'd be nice to have line numbers in that editor. Okay, so this scale here, and that's something that can be hard to see in just one version of the game. Like, how do you force this scale to be one thing or another? Well, it was in a variable, and GCC optimized it out, and so you should have known that. That can be hard to see sometimes. So I'm just going to call it scale. It's a bad name, but I don't know anything better at the moment. It looks like it's a Sine 32. We could call it SP50 as well. I don't like that as much. And then when we're multiplying by 4, both in the cosine and the sine, we're gonna do that. It has the 4 coming first. I don't think that's gonna make a difference. It could. Setting the global before these other two locals. And so as I'm making these changes, I'm gonna keep an eye on this percentage and see if it's getting any closer. I'm not gonna look at the assembly directly right now. I'm mostly just wanting to get the structure the same, so as I flip back and forth between the two versions, I can get a better sense of just keeping the structure the same will help me go back and forth quickly. This happens a lot. So we're setting the prim index directly, not to a separate variable. Both are valid. And I've seen both in the code. So we don't have a separate prim index variable here. Hey, OTM. Good to have you back. What is interesting, though, I'm going to go down and look at that. That didn't improve things as much as I thought it would. It did improve it somewhat, though. It's interesting to me to see like what assumptions match right away and which don't. We get this a lot of times with these pass-through assignments. The first one will be masked and the second one isn't. And it's just M2C not realizing that that idiom means it's a pass-through assignment. And same thing here. The unoptimized MetroWorks compilation will mask things very aggressively. So all that seemed fine. So this first one is less fine. So it looks like it's the Z priorities happening first, followed by the 3F assignment. So I think all that is fine now as well. And here's where the PSP is super helpful. We can get all this ordering correct without having to worry about too much. I thought that these would likely be together. Just couldn't get it to work. Step is being set in a very weird place. Step is typically set last, just as I don't know, the common pattern for these. So we have the same thing here. The default code or the default case ends up showing up very early. I do want to see, I'm going to go look at the assembly for this. I think that this must be an M2C-ism and not what's actually happening. I really doubt that this code. So we're fortunate enough that the MetroWorks overlays were compiled without any optimization enabled. So basically the code as written is what you see just translated to assembly, which makes this very convenient. So when we see code in a specific order, we basically expect it to be in that same order in the assembly. In this case, what M2C, the decompiler, is saying is the next chunk of code is the default case, which basically everything, all the other cases are breaking to, and which looked like outside of the switch altogether. My guess is that that is the case, and that this M2C just put it out of order. But we will see. If there's a go-to there, I'm going to be surprised. So we're going to go to around 134. And what we should see at 135 is a jump to the very end, or near the very end. I highlight these both. So I'm expecting 724 and 79C for what we're targeting versus what we have respectively. I'm expecting that to be way at the bottom. Or at least by way at the bottom. I mean, after the switch. And yeah, they are approximately the same place. So for whatever reason, M2C decided that I was going to take this code and emit it immediately after case 1. I'm not sure why it recognized that this was a switch. And so I'm a little surprised that it doesn't know that this is outside of the switch. So I'm going to skip all this default case stuff. This is the end of the function. I'm going to go down to case 1. And I think we can get rid of all of this casting. and then case 2. So this is around where we were just looking at the scale. And it is going to be a little funny. So we're doing the angle 2 is not needed yet. Angle 2 can probably just be angle. I think it got switched when I did my search and replace. So I think we can reuse distance X and distance Y here as well. Though they're coming in as V1 registers, and V1 registers usually are ephemeral values and not, oh, but they are being assigned here. Yeah, so that's fine. So I'm gonna change this to distance X. And this to distance Y. And those are going to be duplicated now up here. All right, and so then we're grabbing this, what is being called angle 2, and we'll just replace that with angle. Try to clean up this as much as possible. Temp low is not coming yet. Actually, the temp low should be coming. Yeah, so I think all of this is part of this. And we have those together. So following along, we have the cosine and the sine, then this plus equals then I don't think that these are they might be separate variables, they might not be. I'm not convinced one way or another yet. But what I am convinced of is this temp low be in the front, and we should be subtracting it. Mostly the other way around. And then these are out of order. This is kind of a nice thing about the PSP. Absolute value is a built-in in GCC. And so when this is being done, this is the code that the assembly code mirrors this pretty closely in GCC. But on the PSP, there's no built-in for absolute value. It is just a function call. So this var a underscore 2. Trying to track this. So var v1 underscore 2 is going to be absolute value of this. That's how a lot of the GTE functions are as well, which makes them very easy to find on the PSP. Oh, and this is the area that we looked at originally, and now we can get the correct. So it is, they're less than either place, but it is written this way. I thought they were inverted as well. Oh, 150. Yeah, so let's go back up and look. The precedence. Oh, you're right. The shift is on the wrong one. So let's see which one it is. Are we... We're multiplying first. This is one of the few times when the masks are not distinctly 16, 32, or 8-bit. You know that they're probably real masks. The other thing is when the PSP uses S variables, they're most likely they are variables. Okay, so that looks pretty good. Let's just review, see what so this looks like it might be coming in as a sine 16. And so everywhere we have U16 4, it should be sine 16. We don't really control V0 and V1. V0 is the return register. V1 is also a return register, but rarely used. So usually it's just an ephemeral register. How MetroWorks decides to do that is largely based on other things that kind of tip it into doing one thing or the other. So I'm not going to worry about that. Changing other code will either cause it to fall in place or not, and then we can worry about that later. It looks like offset 5 is also going to be signed. Do it this way. Here we're storing a variable early. My guess is it's this these intermediate calculations. So let's do, where are these being stored? Let's look at the stack offsets and see where those are. Is anything else using this? We have something way up here. Oh, and on 127, we actually have something at that stack offset. Yeah, already. And what is that? 127? Just a no, just a coincidence. That's all it is. So we need a variable. Oh, Dizik thinks he remembers that those were timers. Yeah, we could go look at the shaft entity extension and see what it is. So what I think I'm going to do for these for now, I'm just going to do because I don't think temp low and temp S1 are used anymore. I'm gonna just mutate those and then use them as the args. I don't know if that's exactly what I want, but I think it will be a little bit closer. So yeah, we do the calculations and then we take those args. There is a negation for arg 0. So we're storing this into the stack instead of storing it in register S7. I'm going to change this to, let's look at S7 and see if it's the same value. Yeah, I'm going to call this angle as well. I think we'll reuse that register then. Did it give it to us? It did. We're using S8 instead of S7, but that's okay. Another case where it looks like we need a sine value. And we're storing to the stack, but we don't need to. I think we can just go that. And I'll tighten that up. So let's this one. Let's take a short break to go look at the entity extension for the shaft orb and see if it matches what else we've seen. I'm going to do two things. Before I do that, I'm going to grab this, throw it in the PlayStation version and see if we're any closer or further. That's okay. That happens. We may get a little further until we get closer. The PSP version is much closer than we started, about 15-ish% closer than when we started. I'm not too worried about the PlayStation version. So far, we've not made any changes that like really affect the fundamental structure of this. So I'm not too worried yet. So let's look at entity. Shaft orb. So we did have two timers at the beginning. A two-timer. You two-timing shaft orb. And we do have a bunch of space before we get to the parent. So it's possible that's what this is. We'll grab that and I don't think shaft orb is here yet. I was looking at, I think I mentioned other games that seem like they could be interesting. So there's a tweet several years ago about a Ridge Racer Type 4 decompilation project. And the person who wrote this message was saying, it seems like they're working on it independently, that they had 714 out of 1285 functions completed. So we have 8 times, there's about 580 or so functions just for weapons in Soten. So it's crazy that Ridge Racer Type 4 only has 1,285 functions? That would be bonkers if it's really that small. All right, so we're going to add shaft orb. When we think about these offsets, there's two things. There's the address that's, or the offset from the entity start, but then we have to think of in terms of how many 16s are we away. And so if we made all of these timers, that would get us through timer 7. If we don't have a timer 8 yet, that would be fine. As long as we don't have an 8, which we don't. Roaming said 1,285 functions is the dream. Yeah, I think so. Especially like if you include the SDK in that 1285, I don't know if they are including the SDK. That's probably another like 200-ish that get linked in. So yeah, I'm assuming that the original Ridge Racer is probably a pretty lean game, and it would be interesting to look at like how, I'm guessing they use object files for the models for everything, and so maybe most of it's data. I don't know. Maybe their rendering engine is and like collisions and things like that. Maybe it is relatively small. All right, I'm not gonna switch these yet. So I'm not certain. Like when we do a plus equals, that's not normally a timer type thing. It could be, but not usually. And getting the angle, also not a timery thing. So I'm not gonna worry about those fields yet. As long as they're the right type, I'm okay. All right, so I think we got through most of, well, not quite. I want 158. So we have the move again. It's using A1 as a temporary for the subtraction. We can't do anything about that. So we go right into A0. Why the additional register and then the move? I couldn't tell you. We're at the exact same offset, which is interesting. So it's not an alignment issue. Another one. All these seem signed. At line 190. I'm getting there. So that's 10 in. That would be past the end of. It is doing a decrement. We'll get there eventually. Yeah, I think that's still past, though, this, as long as it's not conflicting with this parent. So the parent would be 8 and 9, and then so this will be 9-0. So it'd be fine to have another set of timers there. I don't think that's going to affect anything. I did break something though. Or has this always been like this? I think that's always been. All right. So we're doing a sign extend. That means var A2 needs to be 32-bit, and it looks like it's not. It looks like var v1 underscore 2 needs to be a 16-bit, and maybe that's why we're doing this. Or are we loading this again? Let's look at this. So we're loading this into S7. It's not actually in a variable. We're just referencing it directly. Is how I'm reading it. And just var A2. No, that never gets signed back. So what is V1? So this var v1 is getting loaded from the stack. Not ideal, but I think that's what's happening. V1 underscore 2 is a min. Oh, good call. Do we have a min macro? We do. Let's see if it works. That actually would be very nice. Let's try it. Good call. Where the branch is too early. Yeah, so I think it's having inline. I think the difference here is whether these are getting loaded from the stack or not. Why is this happening now? I like the idea that that was a min. Let's look at what M2C has to say. Oh, it has the var v1 underscore 2 in a separate variable. I don't see a reason why that would have to be. Yeah, I'm gonna go with something else is causing this to compile incorrectly, or I'll deal with it later. I possibly stack issues. This I'm seeing as stack issues as well. Let's go down to 173. Stack issues. So this S2 register, if we can find some other place that we're using it and can attribute a specific variable to it, that would be useful. It looks like it's the same as S3 down on 323, which could be angle. It is being passed to sine and cosine, so I'm fine with angle. See if that clears up. Yeah, let me try that min the other direction as well, just to confirm that's the case. Oh, interesting. So temp 0 S4. Looks like I'm wrong. These are minus equals. Shows the wrong variable. So change this to a plus equals and a minus equals. Then use that here. And it's still going back to the stack. I thought that would have worked out better. S2 was angle though. Are we? This be backwards? What if we did this? I don't want to get too far away from the original meaning. So the worried that is the wrong calculation. So I'm gonna leave it that way. Hopefully something else will force that value in. We're checking that error. It's probably on the stack because there's undefined behavior before reading and writing. Yes. Very, very good. Yes, I agree. I agree. So where was this coming from? This was part of, this should be varv1_2. Nope, it's a separate thing. So it's thank you, Roaming. Appreciate the help. Looks like I tend to do that. Get rid of a variable before I can actually get rid of the variable. And we're still going to the stack, so possibly not correct, but it's always 5C. We're lining up, so even though it's not in a register, I'm not too concerned. Stores are in the right order. Okay, I'm fine with that. It looks like this is going to be an else. And not a not. And these, yeah, typically are like this. That's GCC-ism to take the assignment out and just set the register. Let's try. So this is a decrement. Not sure if the signedness is going to matter yet. Oh, and this whole shifty business is also a GCC-ism. Yeah, I agree that offset A, looking at it now, that does look like a timer. It looks like interesting that it's an explicit check against 0. Let's add that timer. I'm fine adding that one. Am I? I don't know what kind of timer it is. Looks like it has something to do with getting hit. And I haven't added it to ext yet, so let me do that. I will have to... a couple things that I forgot to do. We are dealing with primitives, so we have to update the primitive. Struct for PSP. Had it with 32 additional bits. Why do I always write dummy? We could just put an anonymous bit field in there. And let me grab that shaft orb. And I'm going to take that over to the PlayStation before I forget. And let's do a check for the PlayStation again. Hey, we got a little closer. All right. So let's get down here to after. I think everything else. Oh, there's still some mess up here. No, that's after as well. So all of this seems fine. 212 is the first area, so that's oh, these, it's possible that these are these timers, but maybe not. Maybe this is a different struct. Because this is a hitbox state. Yeah, so maybe this isn't the shaft orb. All right, I'm going to see if these labels are being used anywhere. They're not. Get rid of those. And do we have any other go-tos? No, we don't. I just want to make sure I have all the labels gone. They are. So moving on down, stack pointer. This looks like it's going to be signed. We'll do that. Replace all of these. Hitbox state, that looks the same. Are these out of order? There we go. Register issues. PLS. We have these. No, I'm gonna grab the Richter steps. See what they are. So 40 is ending 1. Excuse me. Ending 1 suggests that it's not the orb. Maybe, I don't know, maybe the check is being done for something else. I don't know. I'm pretty sure ending 1 is not having the holy blast on. $223. So there's something like this where we're going to have a 4 somewhere. Let's clean this up a little bit. So we're loading the value 4, but then it's never being used. Sometimes that happens with mods. Yeah, I agree with that. So first we'll do the increment here. This would be the same as +7. Oh, is this our mod 4? Yeah, I think this is the mod 4. So we're incrementing and then doing a mod equal 4. I think that's what's happening here. Looks like 8. So where's our 4? coming from. Help me, M2C. You're my only hope. Not really. Oh, the G timer is mod 4. Got it. Yep, I like that. Oh, Marcio Laubstein, what are we doing here? Are you looking at the assembly and writing C++ code? Never. Yes, that basically is what we're doing. So this is a function from the Richter boss fight in Symphony of the Night. My guess was that it was related to the orb when you have the holy glasses on, based on some of the behavior. And this target assembly in this middle-ish column is the assembly pulled from the game disk. In this case, it's the PSP version of the game. In the tab next to it, I have the same thing, but it's the PlayStation version of the game. I need to go grab something. And right, we're trying to get the code to compile to the same thing, and we know the compiler flags, we know which compiler, and so the hope is that we can get a match, get it to perfectly compile to the same thing. And so right now we're at around 90% on the PlayStation, 73% on the PSP. In most cases, the PSP and the PlayStation are going to be identical. Not always, but often. Thank you for the mod hint up here. That looked like it worked. And again, I'll just point out that when we have random moves in the middle, sometimes it's because there are equality expressions. So something like this var v0, which is going to turn into an abs, is my guess. Yep. Sometimes less than versus less than equals changes how MetroWorks compiles things. It changes how GCC compiles things as well. Here we have a store and load from the stack. It looks like this abs might just be inline. We can avoid that. Where is our S1 coming from? Or going to? So here, I think we're doing a G timer mod 100, or hex 100, 255. And checking that against 0. That's a fun one. So casting the GCC saw that this only fits within 8 bits, so it could just mask it. It doesn't have to do the mod. Ultimately, MetroWorks doesn't do the mod either. It just masks it as well, but it loads the value into a register, which is the key to what's going on. As far as S1 looks superfluous. Let's just make sure that's the case. Yes. Yeah, so when the initial decompilation gets done using a tool called M2C, you could use lots of different tools to do it. You could use Ghidra, you could use, if you had a license, you could use Hexrays, not Hexrays, IDA Pro, things like that. There's lots of different decompilers, but that'll give us this initial C decompilation. But in this case, I didn't try the PlayStation version, or sorry, the PSP version. If they compile on a longer function like this, maybe you'll get 50 to 60% match. And so the rest of it is just the long process of getting everything else to match. I'm gonna check this out. I just noticed this. And along the way, knowing what is and is not worth looking at. So R means the registers being used are different. At this point, probably not terribly important. Things where we're loading or storing to SP stack pointer, also probably not terribly important to look at the moment. 181. That kind of looks out of order. I'm not going to worry about it though. And so what I'm want to do is try to get this to match as closely as possible to the PlayStation. If I can get the PSP at the same time, that would be great. But I'm not too worried about it. 232. The hint that this is not an explicit check against 0, but just a truthy check, is the additional SEH instruction, which is sign extend. When MetroWorks compares with a immediate value, it will extend the 16 bits to 32 bits and do the comparison. Otherwise, it just checks the register for 0. This prim load looks out of order. Probably is not happening till, yeah, right before the loop. So our position X, okay, so this is what I claimed earlier, and now I feel vindicated. GCC is loading this on the GCC side, which is PlayStation. We're loading this position X, and GCC says, or sees that position X minus a constant is always going to result in the same thing. And so instead of doing it down here on line 252, it's going to stick it in a register and then just reuse the value in that register every time, since the expression will never change. That isn't what's happening, though, or was not how this was written. We're going to do the subtraction down here, and then we don't have these variables up higher. And eliminating these variables along the way is going to, let me just make sure that nothing else was using that, is going to reduce register pressure, which will in turn eliminate a bunch of the loads and stores to the stack. So all of these are going to be the same way. And this looks much more natural. This looks like something a human would do and not a compiler. We have symbols that are different as well. We have to ignore those. Stack pointer differences, not terribly concerned. We are getting close to where this var S0 is not being initialized. Oh no, we passed it along the way. I didn't realize that it was there. Sorry, backtracking a bit. I'm going to go to right before case 10. That ended up being worse. But we'll go back to there in a little bit and keep going down here. Where was this? Unfortunately, you can't click on the line number. It'd be nice if you could click on the line number here and have the assembly output jump to the right place, but that's not how it works. I can do the opposite. It is nice, though, that those lines are highlighted. The draw mode being set first. Again, another not explicit check against 0. Okay, so that is looking pretty good. It looks like the position X and position Y are getting assigned before the timer check. We have some register issues here. Why is this getting put into A1? Oh, this might be a mod. That may be why. Let's try that, making that a mod. No. No, it looks like it was just and one. Okay. Mod 2. Oh, thank you, thank you, thank you. I'm dumb. I'm dumb. Appreciate chat, as always. We get the load 2. So, yeah, I think it is just a masked final bit. That looks like it works a little better. I'm curious, though, about the extra register. I think I tried... Is this the one I tried to make a ternary earlier? We can try it again. Yeah, that didn't work. Yeah, the moves are bothering me, but it's not the end of the world. All right, so this may or may not be interesting. It looks like this I is not I, but yet another index, because it's getting stored to the stack pointer. Or, yeah, getting stored to the stack as opposed to one of the registers, and I being kind of a frequently read and updated value. It wants to keep that in a register. That's kind of curious. Oh, so here's our hint. Is this just a divide by 3? We're shifting left by possibly just a divide by 3. Oh, compilers. You're so fun. Let's let's find this area. If we can even read it. Oh no, the 3 is coming from here. So we just have the shift. Okay, so oh, weird. Yeah, there's something else going on here. So we do the shift by C in one line. And we're going to divide by 7. And then shift back. The plus here, I think, is an artifact of the sign. This may be... I think it's still a divide by 7. Let's try to put those all together and see what happens. Wait, this is a weird one. So we're gonna... The square root piece of it, I think, is fine. So we're gonna divide by 7. That's integer division. And that looks like it's fine. And then we're going to shift back by 12. And that works fine. And so the only thing that we're missing is the move 0. Actually, that is in the right place as well. So what are we missing? We're missing this move from one variable to another variable. So it's possible that there are 2 variables involved here. I would buy that. But it looks like this is the correct construct. So the thing that we're missing is there a separate variable or not? Possibly not. Yeah, it does look like a float divide, but we don't have floats, so I think this is the right math. The only thing we care about at the end is what's in S6. And so when we come down here and see where S6 is being used, is it the same? It looks like it. So it really is just then the register allocation. I'm gonna go with let's see if it works out, and then if not, we'll go fix that. That helped the PlayStation a lot, though. Let's go look at it on the PlayStation. Yeah, all of this, with the exception of this register value and stack value, everything else is the same. So I think that is the right expression. I think GCC was GCC was optimizing this. So instead of doing the divide by 7 and then shift by 12, it was doing a divide by 7,000, which we think of like logically as being the same thing. And so we have macros for this. I'm going to write this in a slightly different way. I think they're in types. Don't we? Where's, no, maybe it's in common. It should be in types, I think. Yeah, so we have I to float and float to I. Float to fix is a shift 5? That doesn't make sense. Anyway. And so we could see if this makes it read clearer. So we're going to take an integer, we're going to convert it to a float. Float being a bad name for a fixed point value. Then we're going to do the divide by 7. And we're going to convert that float back to an integer. And oh, where is and we're going to take all these parentheses and act like we're programming in Lisp. So here's our but we don't end up with the same thing. Did I do this backwards? I am going to get rid of the extra. Oh, yeah, I did it. I did do it wrong. So our float, or our I to float, is inside the square root. And that makes sense because that gives us extra resolution for doing the square root. The nice thing about doing fixed point math is that it's the same as just integer math. And then so here we're going to do float to I. And then that gets rid of that. And so this ends up being the same expression then. The interleaving of these other instructions is interesting. It's not typically what happens in MetroWorks, but in this case, that's what did happen. So I like that a little better. I think that reads a little easier, and you understand why why those operations are being done. 309. Yeah, I agree, roaming. It looks like it could be an additional variable. I'm not sure. The S6 that ultimately gets assigned is what is used. And I've seen S2 used as an ephemeral register in the past. So I'm not gonna try to optimize it yet. Once all the instructions, like all the actual like operational instructions are fine, then I'll go back and fix variables and okay, so here we're supposed to be shifting by 16. Shifting what? That possibly left over from these instructions above. Getting close to the Tama step. Oh, thank you. I didn't realize that I was still on the PlayStation version. Did I screw up? No, I didn't screw up, but we're not quite there. Makes sense that B2 would come after R. I like that. An additional mask, that's not necessary. I said it was unnecessary. What's going on here? Okay. That R2 would be set after setting draw mode in this case, but not in this case. Make this a else if. It looks like, and maybe I'm reading this wrong. No. So even though these are, maybe they're not. Maybe they're not assigned here. Yeah, okay. Let's say, they were being assigned inline. Can we, yeah, we can't do that. I was gonna try to do them inline up here, but that's not gonna work. Because those will be out of order. Yeah. Again, another move that hopefully will be gotten rid of in a different way. Stack versus register. Not here. All right, so this loop it looks like the pos X is happening up in the loop itself after the I increment. But it looks like much after the I increment. And the font print call is PlayStation specific. I don't see a jump and link down here at the bottom, and I don't see one that we're missing otherwise. All right, so what are we doing? Oh, that's right. I thought that there was a different variable that was being used here other than I, and so I'm going to introduce that. I don't want to call it K because it doesn't make sense for K to be outside of this loop, but I've already used J. So, not this one. This bottom one. I is not used for anything except for tracking the loop. And where's our +3? So I think that's correct. Yeah, I think it is something other than that. And then it would be interesting to go look at the like JP 1.0 or the HD version and see if this TAMA step comment is there. It's possible that this was added in the US version, and so it should be a if-def specifically checking for that. So that gets us to 90% on the PSP. That's pretty good. Let's see about the PlayStation. 95 on the PlayStation. Not bad. Our stack is still too big. That means we have too many variables. Oh, interesting. Did I not? I just pasted this. So this looks like a bug fix on the PSP version. This is specifically checking for step to be not equal to 2. Whereas and these wreak havoc on formatters, but I could format this in a slightly different way. It looks like, yeah, it's equality on one and inequality on the other. Joy. So register issues. Basically, I'm going to go through now and scan. If it's just register issues, I'm going to make another pass and go through and update comments. Not comments. Basically, just try to trim and get rid of as many variables as possible. 160. There is this negation. And those are, yeah, they're not variable registers. A register difference. Lots of register differences. 290. The negation looks like it's on A1 and not A0. Again, that might be a difference between the two, or I just screwed up. No, never mind. Negation should be on A0. Possibly that's happening before, like up here. We'll have to look at the PSP. Yeah, all that did was invert this subtraction. So something is causing those instructions, though, to be inverted. It does look like the same thing, just the wrong order. And there's no issue like with that. It's gonna, from a logic perspective, there's no issue. Obviously, it doesn't match. Register issues. So it's mostly register issues on the PlayStation. I'm pretty happy with that. Let's take this back over. So I think the PSP is going to be where we figure out where those variables are that we need to fix. So same thing here. We have about 16 bytes more on our stack than we need to. I'm going to go clean up as many of these as I can. And this is mostly just time consuming. Having these declarations doesn't hurt anything. The main thing is just getting rid of them safely. I don't think this is used anymore. And there's a couple different ways you could do that. You could just delete them and see what errors you get. I tend to just go through them one by one. Many of these probably will end up going away. Just have to find the ones that are going to do that. So we have 4 that's being used and 2. I guess 5 is being used as well. Almost there. Okay. So the focus really should be on the named ones, but not only, or the unnamed variables, but not only those, because there will be others that need to go as well. So the way that I typically do this is to choose a variable, and usually I do that by looking at what registers are being used. The S registers are typically used for variables. And so the first thing I see is on line 48, S5 is being used. Unfortunately, that ends up being an ephemeral value. MetroWorks does use the S registers for ephemeral values, but it also has a strong affinity to use the same register for a variable. When I see an S register used as a variable, it's kind of disappointing. A little sad, because that's one register that I won't be able to tell. Likewise, this S4 on 53. That looks like that is ephemeral as well. And by ephemeral, I mean it represents some intermediate value that we wouldn't think about as being stored in a variable. Okay, is this S0 going to be our first one? On line 63. This is part of our switch. Anything in there is not going to be used either. Striking out so far. Let's get to our first. Let's prim. Prim should help us. So for prim, we're using S0, the S0 register, and that appears to match up with the source as well. It's not always going to be the case. Like down here on 104, S0 ends up getting used for something different. But at least to start with, S0 does seem to have the same meaning. Let's go down to 198 and just double check. Yeah, unrelated. And it does look like it's being used again for the same thing. So I think we can somewhat safely say that prim is S0. Prim index ended up not getting used. I'm gonna get rid of that. All right, so that's our first one. First of many. Slogging through. Is S1. So then sometimes you get these where S1 is, oh, I'm way too low. S1 is being used for the value that's being used in the mod. And that's, yeah, that's not going to be anything. These are, can be boring. I'll put it that way. The stack pointers actually are kind of nice though too, because they do the same thing. Typically the same variables stored at the same place on the stack. Not always, but often. So if we go down to 65 and see what is being pushed to the stack. Hmm, 68. That is the self. Okay, so that's the top of our stack, which is arg0. I mentioned A0 and V0. Sometimes we can control those by tweaking how comparisons are done. Not seeing anything obvious around that area. We have S1 and S7. They're being used the same way. It's on line 82. That looks like I, yeah. So I should be S1. The order that these are declared actually can influence or affect this. I don't think it is doing that right now. That was a shock to me when I saw, it was about a year ago that somebody pointed out that the declaration order can influence what register gets chosen. I'm going to do this. I'm going to go a slightly different route. I'm going to find J. And see what register gets chosen for J. Interesting. So S1. So J is actually I. So I chose J because it was an inner loop. But this looks like it's actually I. And that probably lets us get rid of K, I'm guessing. So I'm going to get rid of J just to make sure that I didn't miss anything. I did miss one. And then K I'm going to get rid of and replace that with J. Why does it matter? It doesn't, but that's how I like naming things. And are we closer? Not yet. And so J was, go find J again. Now the outer loop on 261. J is going to be stack pointer 30. And right now we have it at 78. And as we go, we can keep checking back on the PlayStation. I think it's only, things are only going to get closer and closer. Like that was actually a pretty big jump. About 1%, just tweaking variables. Pause X will be next. I think this is where probably most people give up. Because why would you ever want to do this? 4C, stack pointer 4C is... and 4-8. The stack pointers help us identify the ordering as well. The smaller the number gets, likely the lower it is defined on in the variable declaration order. So this J, for example, I might be able to move this way down, and it may end up being closer to the actual value. In this case, not, but we have more to go. When the ordering affects things is odd, and I'm not good at predicting. What I should be able to predict, though, is if two things are using the same location on the stack, they likely are the same variable. And the order of these actually is looking very correct. Pos Y, I'm guessing, is going to be... oh, it's not. I would have expected this to be on the stack as well, but it gets put into register S8. And that ended up falling to be the same thing. What we're really looking for is when does this... when do we hit a register or stack value that we've seen before, and so far we haven't done that. This one is 34. So about 16 bytes away. Scale is... oh, did I do that wrong? I might have done that wrong. No, I did that. 50. VARS4 is 3C. Nope, 3.8. 3.8. Yeah, we want that descending, right? Yep. Okay, distance X. Five, 8. And so I'll put these in order along the way and hope that these start working out to be the right thing. That would make me think that distance Y is probably up here, close by. 5, 4. Direction is register S5. Angle is S7. Okay, this is S6. Did we have S6 hit? No, it doesn't look like it. Now we're 4C and 4-8. For C and 4-8, we have pos X and pos Y. So prim X and prim Y are pos X and pos Y. So somehow these values are getting put into registers S3 and S4. Do we have S3 and S4 yet? We don't. Yeah, I read that wrong. So eventually, oh, and we're going to S4 and S2. Okay, that's fine. That's fine. 6C and 6-8. I don't think we need to know that yet. So this is S4 and this is S3. And again, we don't have any of those either. RA0_2. This does look like abs, but we have other, or sorry, min. We have other cases. So this ends up being A1. That's fine. We're going into but the sign value there is getting pushed to the stack. No, I'm reading that wrong. We're pushing the value A1 to the stack. So 54, if our A0 is 54, it should be 5C. So far, I'm not seeing anything that's duplicated. I'm going to move this up, though, to where I would expect it. Okay, 5-4. I think we have a 5-4. Yes, distance Y. Tempo is distance Y. So this is a minus equals. And that was a big one. So we still don't have the right location on the stack, but it is going to the stack. And so this temp1 S3 is going to be distance X. Uh, 135. These are backwards. And then my guess is that these are backwards as well. I'll come back to those in a bit. That should get rid of temp low then. And this temp S0, not that one. So we found one. One done. A lot of work for one. What was distance? There's one more in here somewhere. There you go. Okay, 285. We'll get this. We'll get this. No problem. This ends up being S2. Do we have an S2? Of course not, but now I think we have all the S registers. Looks like it. 137. We're getting there. This is S2. Could it be that easy? Could be. That was a big one. I'm a little surprised it took that long to get to this point, but at least we're here. Offset 68. This looks like a new variable as well. And we'll move that one up. Looks like there may be one more real variable in here. And this is 64. All right, we're almost there. Oh, 160. The order of this addition is wrong. And that's because of the plus equals. The add looks like it's in the wrong order. Let's try moving. I don't like that. So if this, the add being in the wrong order, I don't like. But I'm going to do this. I'm going to make this one the same format. Okay, that definitely is the wrong order. Oh, this is odd. I'm not sure why they would end up being so different. So the load order here is wrong, but then it's corrected by the order there. Val minus equals negative x. Yeah. Yeah, unfortunately, MetroWorks is too literal for that. Odd. Okay, what? So oh, we have one more. One more. This far A0, 187. maybe this will be the one. I know it's going to 60, so it is in the correct place. All right, and tongue-tied. Our stack size is correct-ish. Var A0 is a pal. Oh yeah, that's a much better name than Var A0. What did I? Oh, because I have a space in here. Let's check the PlayStation. Very close. Another percent. So let's look at the PlayStation and see what it's not happy with at the moment. So 42, a register it doesn't like. That's out of our control. Register choices. If we're just at register choices and selection, this looks like 127. Looks like this might be out of order. Oh, I can't do that. Can't do that. So it's going to be little things like that where the ordering ultimately affects how the registers are loading. This is wrong. Yeah, that's wrong. Are these the wrong way? I think those are still wrong. Oh, they're wrong because I wrote them wrong. I think this is correct. Yes, I think that's more correct-ish. Slight improvement on the PSP. What I want to find is do we have any big instruction differences besides register selection? Because if it's register selection, then it's mostly going to be just trying to tweak little things. So here's the first thing that I see, 263. It looks like T2, the subtraction order is wrong. So are those, it may be reasonable that those are being done out of order. Oh, they're being done out of order because I put them in the wrong order. I put them in the wrong order for some other reason, but that seems wrong now. Registers. So are we pretty good? We're pretty good, just registers. Let's try again on the PSP. Much better on the PSP. 95. And what are our problems here? I'm hoping that it's just registers on the PSP as well. Working through registers on the PSP, I find a little bit easier. So stack, I'd put in that same category. 139. I think this is inverted, and actually, if this is just inverted, this may be a relatively large one because it would be changing a less than to a greater than equals. And that has some effects. It's not, we're backwards here though. So we need the second load. Let's change this and switch it this way. Again, I'd be happy if this is it. It's not. So we tried to make this a ternary earlier. I like that idea. Let's try it again. Because we need one load. RB1 underscore 2. If they're less, keep RB1 underscore 2. Otherwise, it's going to be this field. Yeah, and the issue is here. We need that initial assignment. We can't. So we need this first. Duh. Okay. I just sometimes you stare at things too long. The correct order of the operands and the operation. That tends to fix things. Possibly something here on 153. we're loading this into S6. S6 we originally had as distance. I don't know if this is... That works in a very strange way. I don't think that... I think that's a fake. I'll try it here as well. I think it's a fake, though. Fake is... just means that it gives us the right result, but it's probably not the way that it was written. So I don't like it, but I'll keep it for now. Unfortunately, it could cause some other issues in the future. I do think that this is going to be written like this, but I don't know why this one would be written like this and the other one not. That doesn't make sense to me. Yeah, the ordering of these operands is wrong again. And I don't see a good reason for one over the other. So there's a few mysteries left yet to solve. 262. Okay, here's a hint. We're loading the value 3, but not doing anything with it. I'm gonna put this at the bottom again. It's going into register S6. Oh, and we know what S6 is, which is distance. Ah, this could be a thing. This could be a thing. Let's go to 262. So kind of in the middle of these. It's a weird thing to do, but then when we are doing this addition down at the bottom, yeah, it's out of order. So this, clear why the distance. And we're moving away just a little. 271. S2 was this value. I don't think we're going to get this today. Yeah, there's a few more things that that still need to be solved. I'm going to take this over one more time, look at it on the PlayStation. Yeah, something we did the PlayStation was not happy with. So I'm going to come back. I might work on this a little bit tonight and see if I can figure out what the remaining issues are. But it is looking pretty good overall. I'm hoping that that it can be solved. I don't think it needs to go into the permuter or anything. I think it's just a few things remaining. So what are we doing? We've been decompiling for a long time. Too long. Boy, how long? 3 hours. Sorry. 3-hour stream. Symphony of the Night. The Richter boss. I will be back tomorrow. I'm late. I gotta go. Bye.